Welcome back! Today we're doing our part 2 with numbers 3 and 9. Why 3 and 9? Because when you're doing divisibility rules for 3 and 9, you add, which is very unique compared to all the other divisibility rules. So let's think, why is that? So let's start off with a number, just to try and expand out from that one. Let's take a number, let me think, 729. Okay, we have 729. So, these are all digits. So we need to make it into a form that's like, it's not going to use the digits. So we make it 7 times 100 plus 2 times 10 plus 9 times 1. This is important. There's two ways to do it afterwards. One with modular arithmetic, and one with just plain old addition. So let's do it the first way. So 100 can be divided up into 99 plus 1. Then the 10 can be into 9 plus 1. Then the 9 will just remain the same. Why do we make it 99, 9, and nothing? Well, one thing you notice is that 99 and 9 are both divisible by 3. And we're trying to divide this by 3. And one important rule about number theory is that when you add two factors of a number, you'll still have that factor. So these numbers, 99 and 9, you add them, they're both divisible by 3. If you add them up, they'll still be divisible by 3. Which is true, because 108 is divisible by 3 when we add it. And that's the same when we multiply. If we multiply 7 by 99, it will still have the same divisors of 99, like 3. So it'll still be divisible by 3. So, what we can do is we don't need to worry about those 99s and 9s anywhere. We can just remove it. We get 7 times 1 plus 2 times 1 plus 9 times 1. Which is, coincidentally enough, just the digits when you add them up, because 1s are essentially obsolete. So we can just remove them, leaving us with 7 plus 2 plus 9. That's kind of cool, isn't it? This also applies with 9, because 99, 9, and nothing are also divisible by 9. That's kind of cool, isn't it? Let's try this a different way. It's modular arithmetic. So, for those of you who don't know about modular arithmetic, I'll probably cover it better in another video. So if we're trying to divide this by 3, if it's divisible by 3, then it must be congruent to 0 modulo 3. That's an important thing to know. So, yeah, let's go back to what we did before. 7 times 100 plus 2 times 10 plus 9 times 1. We're going to keep the digits because we want to prove that we add them, so we have to keep them. So 110 and 1 are all congruent to 1 modulo 3, and what essentially that means is when you divide it by 3, you'll get a remainder of 1. So if we remove all those numbers and replace them with 1s because they're congruent, so it won't matter, we get what we did before, 7 times 2 times 7 plus 2 plus 9. Then when we could do it a step further if we want to actually test if they're divisible by converting them into this one is 1, this one's 2, this one's 0. We add them all up, we get 3, which is congruent to 0. So, yeah. Now the second question is, as we learned in the last part, how does this apply to numbers in other bases? Let's erase up some stuff here. Why 3 and 9? Why them? Well, one important coincidence that's here is that 9 is 110 minus 1, and because we're working in base 10, this must be a good coincidence, isn't it? So let's try, we have a conjecture now. What's our conjecture? That with the base n, with n minus 1, when you're dividing by n minus 1, to check if it's divisible, you add the digits. So, let's try and prove that. We already got this idea, so let's try and prove it. So let's say we have a number, I call it A, B, C. We're going to try and say it's going to work for n minus 1. This logic is going to work for n minus 1. So what we did here, with 729, we divided it into its original form. Over there. So then what we do with ABC, do the same exact thing. But because this is base n, we do n squared plus b times n plus c. And one thing we have to note is that all these numbers are congruent to 1 modulo 3, which is what we're dividing by. Modulo 9. Let's say it's modulo 9 here, okay? Just to make it consistent. So modulo 9. So that means these numbers all have to be congruent to n modulo n minus 1. Not these numbers. Because, yeah, no, they actually should be congruent to, what am I saying? So, the easier way is to separate it into 2 parts. One which is congruent to 0 modulo n minus 1, and 1 modulo n minus 1. So we can test it out better. So if we do that, we get A equals to modulo n squared minus 1 plus 1. B root to n minus 1 plus 1. And C is congruent to 1. That remains the same. Actually, no. What is it? This will be plus 1. So, these numbers have to be divisible by n minus 1. Because they're supposed to be congruent to 0 modulo n minus 1. So they must be divisible. So one thing we know is that n squared minus 1 is the conjugate of the difference of the squares. So it'll already be divisible by n minus 1. N minus 1 is here on for B, and 1, it's just 1. It's congruent. Yeah. So that means we proved our idea that with base n, with n minus 1, when we're dividing it, we don't need to check if it's divisible. We can just add the digits, A, B, and C. Okay. Let's try an example with this. But then there is one other add-on. Because it also works with 3 in base 10, because 3 squared is 9. If n minus 1 is a perfect square, then we also include its square root. Okay, so let's try one. Let's do base 6. Base 6. Base 6, okay. So let's have a number 1, 2, 2. Is that divisible by 5? Well, one thing we know is that 6 minus 1 equals 5. So we just add the digits. 1 plus 2 is 5. And 5 is divisible by 5. So that means 1, 2, 2 in base 6 is divisible by 5. And if we test it out, 36 plus 12 plus 2 and 0, we get 50. And 50 is divisible by 5. We already know that because it ends in something divisible by 5. Why do we know that? Because we've gone over it in the last video. So, let's actually try one in the normal base 10, because that's most likely what you're here for. Base 10. Let's get a number, let me think of one. 9, 0, 0, 0, 1, 1, 1, 3, 3. Is that divisible by 9? Well, let's think. 9 plus 1 plus 1 plus 1 plus 3 plus 3 is 18. And 18 is divisible by 9. And one also important factor, if we don't know that 18 is divisible by 9, we can do this one step further and just add the digits again, because this can work with any number. So, this number is divisible by 9. Is it divisible by 3? Let's check. 9 plus 0 plus 0 plus 0 plus 1 plus 1 plus 1 plus 3 plus 3 is 18. And if we add the digits of 18, we get 9. And 9 is divisible by 3. So, yeah. So, I hope you enjoyed this video. We gone over the divisibility of 3 and 9. And also, we learned that in any base n, when you're trying to find the divisibility rule of n minus 1, you just add the digits. So, in part 3, we're going to do some prime numbers. Some very tricky prime numbers. 7 and 11. 7 and 11. You've never learned their divisibility rules when you're in school, so you're going to learn them, and it's going to be very exciting. And you're also going to learn how you prove them. So, yeah. Bye.